It is easy to feel like we are talking to a living, breathing assistant when we use modern AI, but the illusion breaks when you ask it to execute a multi-step task. Tell it to analyze your monthly data, build a spreadsheet, and email the results to your team, and you don't get a finished task. You get a wall of text explaining how you can do it yourself. This happens because generative AI is a passive system. Despite its vast knowledge base, it is currently consigned to a chat window, waiting for a prompt before it can perform any calculation. Under the hood, a large language model is a prediction engine. When you send a prompt, the network calculates the highest probability for the next word, locking that single token into place. The instant that final word is generated, computation stops. The model idles, waiting for a user to press enter. It is like having a brilliant consultant locked inside a room without a phone, a computer, or even a pair of hands. They can outline the steps to solve your problem, but they cannot perform the work. The chatbot design is reaching its structural limit. An infinite encyclopedia is a useful tool, but economic value is driven by the completion of tasks, not the explanation of them. Advancing these systems requires an architectural evolution. This shift moves the AI from a conversational interface to an autonomous executor. This new framework is known as an AI agent, a development that turns a passive text generator into an active digital worker. This requires a few critical upgrades. The first is planning. Instead of immediately generating text, the agent is designed to pause. It uses its reasoning capabilities to fracture an ambiguous goal into a step-by-step logical execution plan. The second upgrade is tool use. Developers give the system digital hands by connecting the model to application programming interfaces, or APIs. These APIs act as direct pipelines into the software we use every day. Rather than typing out instructions, the agent uses these connections to bypass the human interface, triggering actions across different platforms on its own. But the piece that makes this system function is the third breakthrough: autonomous execution loops. When a traditional text model encounters an error, it stops and waits for a human to fix the prompt. An agent reacts differently. If an action fails, the system reads the failure, course corrects, and automatically plots a new trajectory to bypass the obstacle. It operates in a continuous loop in the background. The model evaluates its progress, triggers the next tool, and checks the result, only ending the process when it can verify that the goal is complete. By combining a language model's knowledge with active reasoning, API tools, and self-correcting loops, the AI breaks out of the chat window. It becomes an active participant in the digital environment. This architecture points to a shift in how we interact with computers. We are moving away from manual prompting toward a dynamic where intelligent systems are running in the background of our workflows. Picture a workflow where an AI agent spends the night debugging thousands of lines of code, or an AI research assistant independently conducts a literature review of medical journals while the human scientist sleeps. The nature of human labor shifts. We stop acting as operators who micromanage individual inputs and move into the role of managers who define goals and review the final outputs. Delegating this authority changes the safety landscape. When an AI agent moves through bank accounts and corporate software, we lose the safety net of constant human oversight. This leads to a challenge called alignment, the process of ensuring an autonomous agent's underlying goals match human intent. If miscalibrated, autonomous loops cause the machine's actions to drift apart from what the human wanted. Without a human intercepting mistakes, safety guardrails must be baked in. These constraints forcefully realign the agent with human intent, despite unpredictable environments. Building an intelligent brain is only half the challenge. The future of the field rests on engineering autonomous systems that act reliably on our behalf.